All right, so recording has started. So again, welcome everyone. Thank you for being here for our computer vision workshop for the competition.
Bienvenue à tous encore pour votre présence aujourd'hui. Par rapport à la vision ordinaire.
All right. So usually I'd like to just give us a sense of where we are. So where we are is that we are on the 6th workshop on computer vision. Today is the 29th of April. And okay, go ahead, Andrea. Hello, Andrea. Do you want to go ahead and translate? Hello, Andrea, we can't hear you. It looks like we lost Andrea. Okay. Okay, hopefully you should be able to come back soon. All right, so I'll just carry on and wait till she comes back before I get into the main content. Okay. All right, so we have gone through quite a number of workshops, and in case you missed any of them, they're all available on our website. Okay, so I can show you right now how to access them. I have bookmarked the competition website, but you don't have it. I can put this in the chat. Okay, I'll put this in the chat so everyone can access the website. This is the website. On the website, in the resources and support, you can find all the virtual meeting recordings. Okay, and so we have video and slides. Okay, so we have the PDF version of the slides and the video as well. And in situations where we had other resources like GitHub repository for code, we also provide those links. Okay. All right, so far we have done these 4 workshops, and we have all of the videos, slides, and additional resources available here. Okay, so if you missed any session, it's so easy for you to come here and catch up. And particularly, I want to encourage us to review this particular one, the MATLAB and Simulink with Ross. Take a look at the slides and code. This was run last Friday. I recognize that because it was on a weekday, a number of us could not attend. Okay, so we made sure to record it for your benefit. We had an engineer, or it's a technical expert from MathWorks, the company that develops MATLAB and Simulink, run that workshop with us. Okay, so that was a very good one, and there was a lot of interesting discussion from our facilitator about how to use MATLAB for task 2 of the competition. Okay, so task 2, we require all the teams to use MATLAB, and the resources presented in this workshop will certainly help you go through that task very easily. And it's not easily, but more comfortably. Okay, so please make sure you do that. I just wanted to point that out at the beginning. Okay. All right, I think we have Andrea back. So Andrea, are you back and you have audio?
Yes, I can hear you.
All right. Sounds good. The other thing I want to point out is the future planned events. We have 2 future planned events. Okay. We have next Saturday, we have our first panel discussion, and that's going to be very exciting. And then 2 weeks after that, we have the second one.
Donc, nous avons deux événements planifiés, donc pour samedi prochain et le samedi d'après.
Okay, I want to talk a little bit about the panel session for next Saturday, because I really want to encourage you to not only attend, but I want you to invite other people to attend. It is open. It's not only open to PARC participants. It's open to everyone who loves robotics and wants to learn about robotics in an African context. So we have confirmed panelists. We have different people that we're able to get. They're all African people who are doing very exciting things in the robotics space.
Donc, nous allons un peu parler du panel par rapport à la Pathway to Robotics. Donc, comme vous pouvez le voir sur l'image, on a plusieurs noms de panélistes qui seront présents lors de l'événement.
Right, so
Donc,
we have a
dans
good mix of, oh, sorry, go ahead.
Donc, le panel sera ouvert à tout le monde, pas seulement aux personnes participant à PARC.
Right. We have a good mix of people from industry. We have people from like Amazon Robotics, really big robotics company for the Amazon company here in the US. We have people from NVIDIA. If you use graphic cards, NVIDIA does a lot of things in robotics as well. We also have people in industry, startup companies in Africa, like this 3Farm8 is an African robotics company in Ghana. And Aaron is also a robotics and technology company in Nigeria.
Donc, parmi nos panélistes, nous avons des personnes travaillant pour la robotique à Amazon, à NVIDIA. Nous avons aussi une entreprise en phase de démarrage au Ghana. Nous avons Aaron, qui est une compagnie de technologie au Nigeria aussi.
Yeah, and you know, we have people from the academic background, a professor of computer science and robotics in the US, and we also have Dr. Ayola, who founded, what is the first robotics and AI institutes in Nigeria. So it's really exciting people that I admire a lot. Africans who are really excited about robotics on the continent. And so I think it will be a wonderful time. So please plan to be there. It's same time as now, next Saturday, same time as now on Zoom. You need to register though. And we'll be sending the registration link on Slack.
Donc, parmi les panélistes, nous avons aussi des formateurs, des professeurs. Nous avons aussi des pionniers de l'intelligence artificielle au Nigeria. Donc, par rapport au panel, vous devrez vous enregistrer pour pouvoir participer à la réunion Zoom. Ce sera toujours à la même heure, samedi à la même heure.
One other thing I want to say is that if you have, okay, so two things to say. The first thing I want to also highlight is that this is particularly helpful for people who want to understand, you know, how can I go from where I am to become a robotics engineer? What degree do I need to learn? What skills do I need to develop? What are the opportunities for me in my country or even anywhere in the world? These are questions that we would be addressing during this panel discussion.
Donc, ce panel n'est pas seulement pour juste pour une session d'information, mais c'est plus pour des personnes qui veulent savoir comment débuter, où aller, quelles sont les opportunités liées à la robotique en Afrique. Et toutes ces questions seront, on va en discuter durant le panel de discussion.
All right. And the second thing I want to mention is that I will be moderating the event. I have a few questions that I will start off the conversation with. but I actually would like you to send questions to me. If questions that you would like to ask, you can send them in advance, or you can bring them along with you at the event. Towards the end of the event, I will open up for people to ask questions directly to the panelists. But if you want to send the questions in advance, that could also help me in preparing how to take the conversation.
Donc, par rapport au panel, Kenechukwu sera le modérateur. Donc, vous pouvez envoyer, si possible, des questions à l'avance pour qu'ils puissent harmoniser la réunion. Mais vous pouvez aussi préparer vos questions à vous et les poser durant le panel. Mais il serait préférable d'envoyer des questions à l'avance.
All right, awesome. Do we have any questions? Does anyone have a question at this moment? Not a question to ask next week, but I mean a question about this, or a question about the plan of events. Is there any questions about what we're talking about so far?
Est-ce que vous avez des questions par rapport à l'événement?
Everybody's okay? Any question? Okay, I will take it maybe right now, no question, but if you do have a question, if you're still thinking, please feel free to ask. Oh, yes, sounds like someone has a question. Go ahead.
Pour le panel, c'est comme une sorte d'échange entre nous avec les experts, ou bien il y aura d'autres choses?
Okay, so he's saying that during the panel, is it gonna be like a discussion with the participants and the panelists, or it's gonna be something else?
Oh, okay, good question. This event will have different sections of the event. The main section will be a discussion between myself, and the panelists. So I will have some question to ask the panelists. That's why I asked if you have some questions that you want me to focus on in discussing with the panelists, you can send me those questions in advance. The first section of the event would be me asking questions to the panelists to have a discussion on different topics, okay, about African robotics. And then towards the end, we would allow participants to ask questions. So if people live in the event have any questions, they can bring up those questions. I will take those questions and also ask to the panelists. Okay, so that's how it's going to be.
Donc, par rapport à l'événement, il sera divisé en plusieurs sections. Donc, pour la première partie du panel, il y aura une discussion entre le modérateur et les panélistes afin d'avoir un petit débat par rapport au topic, par rapport au thème. Ensuite, il posera les questions, ses questions à lui et les questions que vous aurez au préalable envoyées, que vous lui aurez au préalable envoyées. Et ensuite, dans la deuxième section du panel, vous pourrez discuter, poser des questions, engager une discussion avec les panélistes directement.
And then the other thing that I want to add is we are reserving about 25 minutes at the end of the session to have a networking opportunity. Okay, now what that means is that at the end of the event, after we have the discussion session, we will have breakout rooms where each panelist will go into a breakout room, and the participants can attend, can join any breakout room they choose to have a more personal conversation or ask more personal questions directly to the panelists. Okay, so for example, let's say somebody here is really interested in starting a robotics company. They want to get some specific advice from maybe somebody here, for example, Elijah, who has started a company, or Elijah, who has started a company in Ghana. you can go into Elijah's breakout room and ask him a specific question. Okay, so this, and get to know him, exchange contacts, keep in touch, opportunity to have those networking interfaces. So that's what we'll do at the end as well.
Donc, à la fin du panel, vous aurez 25 minutes d'échange, c'est-à-dire 25 minutes où vous pourrez discuter de possibilités de connexion, de networking. Donc, des salles de réunion séparées, des breakout rooms, seront créées avec chaque panéliste. Donc, dépendamment de votre intérêt, si vous voulez par exemple créer une entreprise de robotique ou quelque chose relatif à la robotique, s'il y a un panéliste qui vous a particulièrement touché, vous pouvez toujours accéder aux breakout rooms qui seront créés et discuter directement avec les panélistes.
Okay, all right, thank you, Andrea. Good question. Is there any other question?
Est-ce que vous avez d'autres questions?
No, thanks.
All right. Okay, if anybody else has a question, please feel free to ask that. Again, this event will be recorded as well, and so you could have access to review it after the event, share it with others who you think would find it beneficial, so on and so forth.
Donc, comme d'habitude, vous pourrez avoir accès aux enregistrements du panel.
Okay, so now the next thing is I want to do a quick overview of the competition tasks. Okay, I want to do a quick overview of the competition tasks.
Donc, on va faire tout de suite une vue d'ensemble des tâches de la compétition.
First of all, I'd like you all to please fill out a quick poll. I just launched a poll. You should have gotten this poll on your Zoom interface. It has 3 simple questions. One question is about setting up whether you have set up your PC. Second question is whether you have started working on task 1. Third question is whether you have started working on task 2.
Donc, devant votre écran, normalement, vous allez voir un sondage. Vous aurez 3 questions. La première question, c'est de savoir si vous avez configuré votre ordinateur avec Ubuntu 2.20.04 et AROS. La deuxième question, c'est de savoir si vous avez déjà commencé à travailler sur la tâche 1. Et la troisième, c'est de savoir si vous avez commencé à travailler sur la tâche 2.
Thank you. So please kindly go through filling that survey. It's just yes or no questions, should be very quick and simple. Just yes or no questions.
Donc, vous pouvez commencer à remplir le sondage.
So far, we have only six people have filled out the survey. Please, can we have more people fill out the survey so we can get a better picture?
Donc, pour le moment, il n'y a que 6 personnes qui ont rempli le survey. Donc, si vous pouvez remplir le sondage, ça sera intéressant.
Okay, we have 10 people. That's wonderful. Thank you. Let me give it another 1 minute so that maybe the extra 5 people, 4 people might be able to fill out the survey. Okay. And if you're a team leader and you know that your team, you know the status of your team, you could also fill out on behalf of your team. All right. If you haven't done it personally.
Donc, si vous êtes capitaine de votre équipe, vous pouvez déjà vous pouvez remplir par rapport au statut actuel de votre équipe directement.
Okay, so I just want to give us another 30 seconds. Please, we probably have two 3 people who still need to fill out the survey.
So I have one question. The competition will be held in which country?
The competition will be held in Senegal.
In
The
Senegal.
final, and I think you're referring to the final event. Phase 2 of the competition will be held in Senegal.
I think it will be, I thought it will be for Benin.
Oh, why did you think that?
Uh,
Where did you get that information? Okay, well, now you know. All right. Okay, so I'm going to end the poll. We have some, hopefully you can see the results. I think I shared the results now. Okay, so it looks like most of the people here who filled out the survey have set up their PC. That is very good. It means that you're able to follow along and do things on your computer. That's wonderful. One person has not. Okay, so I know that some people have been struggling with getting maybe their computer, they don't have a computer accessible or some other reason. If it is an issue of setting up an existing functional computer, please send me a direct message on chat or send to Andrea right away so that we can see how we can support you as soon as possible. Without a computer setup, there's no way you can, participate effectively in the competition.
Donc, par rapport au pôle, nous pouvons voir qu'il y a une seule personne qui n'a pas pu avoir accès, qui n'a pas pu configurer son PC. Donc, tu peux envoyer un message direct à Kenny, soit sur Slack ou bien sur Zoom maintenant, ou tu peux me l'envoyer par Slack aussi.
All right, and from the poll, about half have started task 1. That is very good. No, not half. Most people have not started task 2. So maybe it looks like you're starting with task 1 and then before you go to task 2. I think that is a reasonable plan. So I think that's okay. I'm happy to see that most people have their computer set up here. That's very good. Again, if you haven't, the one person who said no, please, if it is something that we can help with in terms of advice on how to set up, please reach out to us.
Donc, pour la personne qui n'a pas pu configurer son PC, n'hésite pas à envoyer un message pour expliquer ta situation.
Okay, so let me stop sharing that. We can move back to our slides. I wanted to do that to get a sense of, the room, to know who has started the tasks. And it looks like at least half of us have started task 1. Okay, so that's very good.
Donc, il semblerait que la moitié des personnes présentes dans la salle Zoom ont déjà configuré leur PC, donc c'est vraiment, vraiment encourageant.
All right, so I'm going to, again, just go through high level of the tasks. And I want to leave the second hour to focus on the computer vision, or maybe just to answer any questions here. Okay. This is task 1. Task 1 is, the task is for you to navigate through the crop rows, like you can see in this image. Okay. And there are different ways that we will be evaluating your performance using, did you avoid the crops? How long did it take you to finish the task? And did you follow the path correctly?
Donc, nous allons parler de la task numéro 1, qui est de se déplacer entre les cultures. Donc, on aura plusieurs manières de vous évaluer, c'est-à-dire combien de temps cela vous prend pour terminer la tâche et est-ce que vous suivez les lignes correctement.
Okay. There have been some very interesting discussion on Slack about different methods to use. One of the teams asked a very good question about creating a map of the environment and trying to generate a path that would take the robot through. And we discussed about that on Slack. So if you are thinking about what strategies, you can go back to Slack and read some of the conversation. Okay. So the summary is that, yeah, some people are thinking about different ways. If they can build a map of the farm and then plan how to move through, that is one way, but that might not be a very effective way because of the method they were trying to use for building a map.
Donc, vous avez plusieurs méthodes que vous pouvez utiliser pour naviguer dans la ferme. Donc, vous pouvez aller dans le Slack, je pense dans PC, non, vous pouvez fouiller le Slack et voir les différentes discussions qui ont été faites par rapport au déplacement du robot dans la ferme. Donc, certaines personnes ont parlé de créer une carte de la ferme afin de permettre au robot de se déplacer plus facilement. D'autres ont pensé à générer un chemin spécifique pour le robot. Donc, ça dépend de vous, de comment est-ce que vous évaluez la stratégie pour mener à bien votre tâche. Donc, la tâche numéro 1, c'est-à-dire celle de créer, la tâche qui a été proposée, c'est celle de créer une carte de la ferme, n'est pas forcément la meilleure idée à faire, mais tout dépend de vous.
Okay, thank you, Andrea. I think I talked for very long. So I don't know if anybody has any questions. 5 people have started this. Do people have questions about their method or things that they want to clarify? I'm happy to spend maybe 5 minutes just giving some feedback about the method or ideas or anything. If anybody wants to ask, has any question as they are going through this task.
Donc, est-ce que quelqu'un aurait une question particulière relative à la stratégie qu'il a utilisée pour naviguer dans les cultures?
But so for ours, we didn't make the mapping, the good mapping, because the position for the laser, the LiDAR, and how do you call it? The LiDAR,
Yeah.
it be available for the mapping. Yes.
Yes.
Maybe we search to find a good solution for that. Yes.
No, I think that's a good idea, because yes, you're completely correct. The LiDAR cannot capture the crop on the floor because there's a height difference. So you cannot use the LiDAR to build a map that contains the crop.
And so I want to ask you something. Will you move the position for the LiDAR?
Move position of what?
For the LiDAR.
Okay. No, okay, so
It will be possible.
How do I pronounce your name? Is it Hamidou?
Yep.
Hamidou. Okay, so Hamidou, this is a typical problem in robotics, right? When you have to think about the best solution to a technical issue. Okay, technical issue is that the crop is too low on the ground, okay? So you have to think about a different way to solve the problem. You cannot change the environment or change your robot so much to fit your problem. You have to think about what are the other things I can do to solve the problem. Okay. I can give you one hint. Actually, one hint is what I want to cover today in the second part, which is to, instead of using LiDAR, you can use camera, you can use vision. Okay, use vision. You don't need to build a map. I mean, you can build a map, okay, but you don't need to build a map with the crop and then do path planning on that. You can use vision to navigate through the crop row. Okay, similar way that a self-driving car will use vision to navigate between a lane in on the road. You know, you can use a similar approach. So that is one. There are many ways to solve the problem. That is one way. Okay, one way is to do what you're thinking to do, which is build a map and then do path planning. That doesn't work well in this case because you cannot build a good map.
Donc, la méthode, c'est-à-dire la préoccupation d'Amidou, c'était de préciser qu'il a essayé d'utiliser LiDAR pour créer une map de la ferme et Kenichuku lui disait que ce n'était pas, c'est que le LiDAR ne pouvait pas capturer les semences sur le sol parce que il y a une différence de hauteur. Ensuite, Amidou a posé la question de savoir si on pouvait changer la position du LiDAR sur le robot. Et Kene a dit que ce n'était pas possible de changer la position du LiDAR, mais qu'il pouvait donner peut-être une astuce, c'est-à-dire d'utiliser la caméra, c'est-à-dire utiliser la vision au lieu du LiDAR pour pouvoir résoudre la situation. Mais la méthode de créer une carte n'est pas forcément la meilleure pour résoudre la tâche.
Yeah, thank you, Andrea. That was that was good. All right, so that was a good question. Actually that was a very good question. So Himadu, if you have, if you want to discuss more, actually after this workshop, hopefully you get some more idea on how to use different approach. But always happy to chat on Slack to discuss any other idea that comes to your mind or anybody else. Okay, so all right.
So on this, like me and Jakuba, do you remember Jakuba on slide?
Yes.
Yes, we had been asked about.
Oh, that is you. That is you. You are the
exactly.
Other... Okay.
Exactly. Thanks.
Okay. Is your name that one Emmanuel? Emmanuel, is that your name on Slack?
No. For me, it is Amidou, and Yakuba, it is Yakuba.
Okay. All right. Very good. Okay, so but let me, if anybody else has questions, please feel free to ask. Let me move on to task 2. Task 2 is also similar case. This is purely a computer vision problem. And we are asking you to use MATLAB exclusively for this problem. Okay. I don't know if anybody has any questions so far from trying to do this.
Donc, là, maintenant, nous allons parler de la tâche numéro 2, celle de la détection des mauvaises herbes. Donc, pour cette tâche, il vous est demandé d'exclusivement utiliser MATLAB pour résoudre le problème, résoudre la tâche.
Okay.
I have one question. It is possible to create an API for Python and to use the pipeline for MATLAB?
No, I think you asked that question in Slack already, right? Or
Yes,
maybe somebody else. Yakuba asked question.
exactly.
Yeah, no, it's not. It's not. Okay, so let me repeat the question so this, Andrea, you can understand. Himadu is asking whether he can write the code, the software for this task in Python, or at least some part of the software in Python, and then be able to, that the ways you can call or run Python code in MATLAB, and do that so that, and I think the thinking is that maybe the team has more experience in Python, or the team knows how to solve the problem in Python, but maybe doesn't have much experience in MATLAB. And so they might want to solve part of the problem in Python and then use the software they write in Python in MATLAB to complete the task. Okay, so that's a good question. That's a very good question. And that could be a good solution. But the answer to the question is that we want you to use MATLAB alone, okay? And like I mentioned at the beginning of this workshop, the workshop on MATLAB and ROS last week was very good. If you go through that workshop, you will see that MATLAB has so many tools for image processing that makes image processing very simple. And so I don't think you should have too much of a problem fully using MATLAB alone to solve this task, okay? And if you do have problem with it, please, that's why we are here, come on Slack and ask any questions. So we want you to use only MATLAB. So you cannot use Python, you cannot write a Python API for MATLAB to run it. No, we want you to only use MATLAB.
Donc, la question de Hamidou, c'était de savoir s'il pouvait écrire le code par rapport à la tâche numéro 2 en Python et après l'adapter sur MATLAB. Donc, Kenya a dit que ce n'était pas possible. Il est préférable ou il est recommandé ou plutôt obligatoire pour vous d'utiliser MATLAB pour la tâche numéro 2. Donc, vous pouvez aller regarder l'enregistrement qui a été fait le vendredi passé. Les informations qui ont été données sont assez compréhensibles pour pouvoir démarrer par rapport à la tâche 2. Et si vous avez des questions, vous pouvez toujours contacter Kenny pour avoir des réponses. Donc, vous ne pouvez pas utiliser Python pour la tâche 2, seulement MATLAB.
All right, thank you, Andrea. I don't know if anybody else has questions. Any questions, other questions from Hamidou is asking all the questions, all the good questions. But if anybody else has questions, if you have started working on this task, I imagine that you might have some questions. Please feel free to ask. Okay, all right. You can always stop me at any point, but I will move on. Feel free to stop me and we can always come back to that, okay? So without further ado, I would like to move on to the computer vision basics using OpenCV, okay? That's what we're going to focus on for the next 1 hour.
Donc, nous allons commencer à parler de OpenCV pour la vision ordinateur.
All right, so the outline is that we would, I'll just go through these things, setting up, okay, no, well, first of all, going through what digital image representation is, how to install OpenCV, how to process images from ROS to OpenCV, how to understand image properties in OpenCV, and how to do some basic image processing using OpenCV. Okay.
Donc, comme vous pouvez le voir, vous avez un aperçu de ce de quoi nous allons discuter aujourd'hui. Donc, on va parler un peu de la configuration de comment installer OpenCV sur votre ordinateur. Ensuite, nous allons parler un peu sur le process pour utiliser ROS. Ensuite, de comprendre l'image digitale et passer aux bases de la processing image.
Right, very good. Okay, so let's go ahead and start. I want to just point out that this would be in a hands-on workshop. So I have prepared a repository of some code. So if you want to, you might not be able to run well, you can run some of the code, but at the end of the session also, you can also follow with the code I put online. Okay, so I put that on there. You can take a look right away and follow along.
Donc, durant ce meeting, nous allons, en fait, l'atelier sera plus comme un tutoriel de ce qui va se passer aujourd'hui. Donc, vous pouvez coder en même temps que Kenny maintenant.
Okay, very good. So I want to just start with giving you some idea around digital image representation. Okay, and what that means is, you know, how does a computer store or process images?
Donc, maintenant, nous allons parler de l'image, la représentation de l'image numérique et de savoir comment est-ce que l'ordinateur analyse et stocke les idées, des images.
Okay, so this is an image that is from the competition, from task 1, from the forward-facing camera of the robot. This image, I got it from the camera of the robot.
Donc, l'image que vous voyez sur votre gauche, c'est l'image de la task numéro 1. Donc, il a pris sur l'une des caméras du robot.
Okay, so if you can see, this is probably this black area is part of the robot, and then you can see the crops. Okay, moving forward like this. This is the sky. This is the barn. These are the wooden pegs. Okay, this is trees. So this is, you know, like this is a camera view that you can get from the camera that is in front of the robot.
Donc, c'est la vue que vous pouvez avoir de la caméra qui est devant le robot. Donc, la partie noire, c'est une partie du robot que la caméra vous montre. Et ensuite, vous avez le ciel, les cultures, la ferme et les arbres.
Okay, so I mean, for us, we can see this and say, oh yeah, this is an image. But how does a computer store or process this information, this data, you know, this image? Does anybody know how the computer stores this image, and how the computer would be able to understand or interpret this image?
Donc, comme vous pouvez le voir, c'est une image. Donc, la question, c'est de savoir, selon vous, comment croyez-vous qu'un ordinateur va utiliser, comprendre ou analyser l'image?
Anybody have any idea?
Thinking pixel.
Sorry? Samson? Did you want to say something, Samson?
Hello?
Yes. Yes, go ahead.
Je pense que l'ordinateur voit l'image à travers, sous forme matricielle, avec les couleurs de base RGB, par exemple, pour chaque pixel.
So he said that the robots will analyze the image artificially and with the basic color RGB.
Right, thank you, Ibrahim. So that's very correct. For us, we see this and we see color, we see nice color, but computers cannot see color, right? Computers can only see numbers, can only see binary, okay? And so this image is represented as pixels, pixel values, okay? All right, that's basically what the computer will store and process this information. And specifically, like Ibrahim said, one of the encoding approach is to use RGB. Okay, RGB is red, blue, green. All right.
Donc, un ordinateur ne peut pas voir de couleurs, mais l'une des approches de coding serait d'utiliser RGB. Et donc, l'ordinateur ne peut voir essentiellement que des binaires. Donc, la vision que vous voyez, la vision ordinateur derrière cette image sera en pixels.
Right. So you can imagine that this image has a size, and the size is based on the number of pixels. It's in a matrix form. Okay. So maybe the 640 by 480, for example, actually. And each pixel has 3 values. For in an RGB space, it will have 3 values: red, green, and blue. And based on those 3 values, you can get different colors.
Donc, par rapport à l'image, on peut se poser la question de savoir la taille. Donc, la taille sera basée sur des numéros en pixels. Comment dirais-je, présenté sous forme de matrice. Et pour un RGB, un espace RGB, vous allez avoir 3 valeurs, c'est-à-dire rouge, vert et bleu.
Wonderful. So with a mix of red, blue, and green, we can get any color. Right? You can get any color that is a combination of red, green, and blue, or red, blue, and green. Okay, so that is how each pixel here has 3 values: red, green, and blue, and that could give you all different types of color represented.
Donc, le RGB nous permet d'avoir plusieurs types de couleurs, donc différentes couleurs. Donc, une valeur ici aura 3 dimensions de couleurs, c'est-à-dire vert, rouge et bleu.
All right, so that is how computers or how digital images are represented or stored. Okay. All right. I don't know if there's any question about that, please feel free to ask here. But I want to move on to talk about OpenCV. Okay, OpenCV is a library, a software library. Okay, so software library means a list or compilation of software tools or a compilation of softwares. Okay, code. And so OpenCV is a library, that's a software library of different software used for processing images. Okay, used for processing, interpreting images, digital images. All right, and so it's a very popular one, OpenCV. CV means computer vision. computer vision. Okay.
Donc, OpenCV, c'est une bibliothèque open source très connue en ce qui concerne la vision ordinateur. Donc, vous pouvez avoir accès à des softwares, des codes et plein d'autres softwares relatifs à la vision ordinateur.
Okay, I forgot to mention one thing, but a couple of my slides today are I'm using some slides that were used 2 years ago during PARC by another facilitator, Professor Dylan. He's now a professor at MIT, and he organized a workshop for us 2 years ago at PARC, and so I'm using a couple of his slides. I forgot to mention that just to give him the credit.
Donc, certains des slides qui sont utilisés dans ce meeting aujourd'hui ont déjà été utilisés, ont déjà été présentés par un autre professeur quelques années avant. Donc, c'est juste pour le préciser.
All right, so you have access to these slides at the end, as usual. So if you want to go through the process of installing OpenCV, you can follow this image, or you can click on this link here that will take you to the page that shows you what commands to run to install OpenCV on your computer. Okay, but I already did this on my computer, so but for your own interest afterwards.
Donc, vous aurez accès aux slides comme d'habitude dans le website. Donc, vous pouvez télécharger le OpenCV. Une fois que vous l'aurez fait, vous pourrez commencer à suivre les étapes qui seront énoncées aujourd'hui.
All right. Again, as usual, if there's any question, please feel free to ask. I'm happy to go back to any slide if needed. I'm happy to move around to help you answer any questions you have. All right. Okay, so I'm going to move on to number 3, is how to acquire images in ROS and OpenCV. Okay, so we have OpenCV and we have ROS, and they're separate. They're separate software. Okay, OpenCV, like I told you, is for a software for processing images. Okay, ROS is a robotics platform for for controlling robots in real time.
Donc aujourd'hui, on va essayer de comprendre comment vous pouvez acquérir des images de ROS sur OpenCV. Donc OpenCV, c'est une bibliothèque de software, bibliothèque de code basée sur la vision ordinateur, et ROS, c'est une plateforme pour le contrôle des robots en temps réel.
All right. And so we need something that we call a ROS bridge a CV bridge to connect the file format. So different file formats, different software will use different file formats. OpenCV uses this CVMAT file format. ROS uses this ROS image message type for its images. And we need something called a CV bridge to convert from one format to another format. So the CV bridge is what we use to convert from one format to another, so that we can collect our images in ROS from our robot, convert it into a format that we can use in OpenCV to do some processing.
Donc, pour pouvoir faire la conversion, convertir les formats d'une application à une autre, donc vous allez avoir à utiliser CV Bridge, qui va vous permettre de convertir tout ce que vous allez faire sur OpenCV en ROS. Et une fois que vous avez converti, vous pourrez processer les images de ROS, c'est-à-dire convertir de CV Bridge à ROS Images. Donc, voilà.
All right, thank you. So I'm going to do a live coding now. We will code together, or you can watch me and you can also learn how we can write code to to run ROS and collect image from the camera and then convert that image to OpenCV format so we can use it in OpenCV to do some processing.
Donc, Kiné va coder directement devant vous. Donc, il va écrire un code en ROS pour pouvoir connecter les images de la caméra et ensuite les convertir ces images sur un format OpenCV.
Okay, so I'm going to stop sharing for a moment so I can arrange my views here. Okay. All right, hopefully you can see my screen. Again, as usual, I use VS Code. VS Code is a very good programming environment. All right,
Donc,
so I will...
pour coder, il va utiliser VS Code.
Okay. Just give me 1 minute here. All right. All right, so the first thing to do is I'm in scripts. I will create a new Python script. I'll call it image acquisition.py. Okay.
Donc, il va créer un nouveau script qui va appeler image acquisition en Python.
Okay, I will set my shebang there, and then I will do what you usually do whenever you want to start a new Python script to set the main.
Donc, ensuite,
Okay.
vous faites la procédure normale à chaque fois lorsque vous voulez ouvrir un script Python.
All right, so now we have our function. We're going to, once we run this script, we will run the main function only, okay? Now, because, I'm doing this live, I might, do some things a little bit fast, but please feel free to ask me any question. The goal here for this code is that we want to collect an image from ROS, okay, and convert it to OpenCV image type and display that image. Okay, that's what we want to do. We want to collect image from ROS from our robot camera, convert it to OpenCV type, and display that image.
Donc, le but de ce code sera de collecter des images de la caméra du robot et de les convertir sur OpenCV.
All right, so the first thing to do, as usual, is to initialize. The first thing to do is to initialize your node. So you have a ROS node. As you can see, I need to import. I need to import ROS.py. All right, so now I import ROS.py. Should be good. All right. So we initialize the node. We call the node anything we want. I call this image converter. You can call it whatever you want.
Donc, vous allez initialiser le nœud et le nommer de la manière, et le nommer comme vous voulez.
All right, and then remember, if you have been going through ROS, you know that we use subscribers to read information from topics, okay? We use subscribers to read information from topics. So we're going to use a subscriber now to read image data from our camera topic.
Donc, comme avec ROS, on va utiliser un subscriber pour pouvoir lire les données. Donc, on va lire les données imagées. Nous allons lire les données imagées de la caméra.
Okay. All right. And this is only one way to create a subscriber. There are many ways to create a subscriber. This way to create a subscriber only collects one message. Okay. Other ways will continue to collect messages at a particular frequency. But this way only collects one message. And I'm using this because it's maybe more simple for people who are new to ROS to understand. But there are other ways you can create a subscriber that I'm not describing here. Okay.
Donc, il y a différentes manières de créer un subscriber. Donc, cette méthode nous permet juste de collecter un seul message. C'est littéralement le subscriber basic, c'est-à-dire la base pour les personnes qui ne sont pas habituées à cela. Donc, il y a différentes façons de créer un subscriber.
All right, so I'm going to come back to fill out this part. But for now, I also just want to show you the overall structure. We will collect an image type from ROS, and then we will convert that image to an OpenCV type, okay? And for that, we will use the CV bridge. Like I mentioned before, we need to use the CV bridge. Okay, we don't have it yet.
Vous allez utiliser CV Bridge pour convertir le format ROS pour un format OpenCV.
Now you need to install the CV bridge, of course. So when you're running this, before you can run this, you need to install the CV bridge.
Donc, avant d'écrire cette partie du code, vous devez installer le CV Bridge sur votre ordinateur, je pense.
So we can use, it's usually good practice to use a try and accept bracket when you are working with, when you're trying to do this conversion. So I just do that.
Donc, il est préférable de travailler avec des parenthèses lorsque vous voulez faire une conversion.
Okay, if you have any specific questions, please feel free to ask. Anything that's not clear, please.
Donc, s'il y a quelque chose que vous ne comprenez pas, sentez-vous libre de poser des questions.
All right. Okay, so I'll just go back now to maybe explain a little bit of what this is. So with this line, we want to store we want to store the image that we get from ROS, and then we want to use this function that will convert image from the message to OpenCV type. Okay, so we're going to add the image here and say this is a RGB, or other way is BGR, and we want to convert that to OpenCV data type. That's all this is doing. Okay.
Donc, si vous regardez sur la ligne 13, c'est pour stocker l'image. Ensuite, sur la ligne 18, c'est pour convertir l'image en CV format. Donc, vous avez le nom de l'image pour pouvoir la convertir en CV.
Okay, so then I also need to import OpenCV. This displays the image in window. Okay, so once we have the image in OpenCV, we can now display that image in a window. Okay, and then finally, we can save the image to our computer.
Donc, une fois que vous avez converti l'image, vous pouvez maintenant l'afficher sur une fenêtre.
Okay, we can say.
Ensuite, vous pourrez l'enregistrer l'image sur votre ordinateur.
Okay, so we save it as a front camera image. All right.
Donc, vous allez le nommer Front Camera Image.
And then finally, I'm just going to copy and paste something. And this is just a way for us to be able to view the display window without without it closing very quickly. Okay, so that's just to hold the script until we can press S and then the window will close. All right, just a simple thing to do. All right, so that's all. That's a relatively simple piece of code. The one thing we need to add though, we need to add which topic we need to collect the image from. Okay, which topic? That is the question here.
Donc, ce qu'il vient de coller, ça vous permettra de fermer l'image en utilisant juste la touche S.
Now the topic is camera/image raw. Okay, and how do I know that? You can ask me, how do I know that? I will go to, we can get that directly from Ross. Hopefully you can see my screen. I'm running. Yes, okay, you can see my terminal. All right, so I'm running task 1. This is RViz. RViz will give you the camera information, all the sensor information. It takes some seconds to load.
Donc, vous pourrez ajouter le thème et vous pouvez l'avoir directement au travers de Ross.
All right, so Gazebo is also open here, but it's still setting up, so it might take a few more seconds.
Donc là, il a run le code pour voir ce qui se passe sur Gazebo et sur Ross.
I don't know, it's taking a little bit of time. Okay, all right, there we go. So the robot has shown up now. You can see the robot here. We can see the everything. All right. So what I wanted to show you here is you can see what is the image. This is the image that we want to collect. This image here is the image from the forward camera on the robot. Okay, there's a camera in front of the robot. This is the image. If you see, this is what the camera is seeing. You see, if you look here, this is what the camera is seeing. So that is this.
L'image que nous voulons collecter, c'est celle de la caméra avant du robot. C'est de l'image à droite. À gauche plutôt, je pense.
Yeah, and so if you look here, you can see this is the image topic, okay? Camera/raw. So that is what I copied, okay? That is what I copied. Camera/raw is the image topic. And that's where I got it from.
Donc, vous allez sur Ross, et ensuite, vous pourrez copier le thème de l'image.
So that's
C'est
why
ce
I have it
thème-là.
here.
C'est ce thème que vous allez mettre dans le code.
Okay, so you can put the topic, and then the next thing that you put is the image type. Okay, so let me show you how you can find this image type. You can
Donc,
actually do it from here.
ensuite, vous allez insérer le type d'image.
So you can use what we call the Ross topic info. And if you add Ross topic info and the image and the topic name, you will get the image type.
Donc, on va utiliser ce qu'on appelle Ross topic info. Et si vous avez aussi le nom du topic, vous pourrez avoir le type d'image.
All right, so you see it here, this is the type. It is an image type from the sensor message category. All right.
Donc ensuite, vous allez copier le type d'image et l'ajouter après sur la ligne 14, après avoir écrit le topic name.
I'll close this. So this is the image type. I'm going to now import that image type. So it's from sensor messages dot message import
Donc,
image.
il va importer le type d'image.
All right, very good. So I think that's all that we need now to do. Now we can, okay, one other thing we need to do is, this is a new file. This is a new Python script. For you to be able to execute this script, you need to set it to be executable. Okay, so you can go to your terminal, find where the script is. You see what I'm doing at the bottom here. The script is here, image acquisition. Let me raise this up.
Donc, comme vous pouvez le voir, c'est un nouveau script. Donc, vous allez aller sur la partie terminale et donner la localisation du script.
All right, and you just need to run this command, chmod, okay, +X, and the name of the Python script. And
Ensuite,
that's
vous
all.
allez faire la commande qu'il vient d'écrire et le nom du script.
If you're curious about that, you can always go online and Google how that works. Okay, so I'm going to run the script now with the task 1 open again so that we can collect one image and display it in OpenCV. Okay, so I'm going to do it again. So in one terminal, I ran the one terminal, I ran the launch file for task 1. And the other terminal, let me use this one.
Donc, sur l'un des terminals, il va lancer le code de la tâche numéro 1.
Okay, so now I can use the Ross run command to run this Python script, but I need to wait first for the robot to get set up in Gazebo.
Donc, il va juste patienter avant de run la commande Ross. Il va patienter que Gazebo et Ross fonctionnent correctement.
All right, now everything looks Everything looks good. I can run this command.
Donc ensuite, vous pourrez maintenant lire la seconde commande.
Oh, I did not spell acquisition correctly.
Il faudra faire attention à comment vous écrivez votre commande.
Oh, I see. Sorry, give me one moment. Let me just. All right. So now I have this. This is the image from OpenCV. So it has captured one image from the camera, and once I close this, it will see that it will save this. It will save this in my directory.
Donc, comme vous pouvez le voir, c'est l'image sur OpenCV. Et si elle clique dessus, ça va directement s'enregistrer sur la plateforme.
All right, so this is the image it saved. See, front camera image.jpg. So that was saved. I'm actually going to move it into scripts. I'll move it into scripts.
Donc ensuite,
Just
l'image,
easy.
lorsque ce sera enregistré, vous la déplacez dans le script.
Okay, so that's the first thing. Let me go back to here. That is the first thing, how we can acquire image from in ROS to OpenCV. So I showed you how to do that. This code will also be in the GitHub, so you can also look at it more detail and pay attention. All right.
Donc, on va continuer dans les slides. Donc, c'était pour vous montrer comment acquérir une image sur OpenCV. Et le code sera disponible sur GitHub.
Any question about that?
Est-ce que vous avez des questions?
Yes.
Yes.
It is possible to specify how can we detect, for example, the weed or the culture?
Yes. We're going to go to that next. I just want to, this first one is how to collect data and how to interface between between ROS and OpenCV. Next, we will look at how to process the data, the image that you get from the camera. Okay, and that will cover your question. Yes,
Donc,
go ahead.
La question, c'était de savoir si on pouvait directement détecter les cultures. Donc, on va parler de ça dans quelques minutes.
Yes, is this Ali? You're raising your hand.
Yeah, I have a question.
Go ahead.
Okay. Since you asked me to complete task 2 with MATLAB, does MATLAB have its own CV bridge or something like that?
Yes. MATLAB has everything that you need to process or capture image from ROS and process image in ROS. All of that. Did you take a look at the workshop last week?
No, I was not there.
Okay, so that was covered last week. If you take a look at the video and some of the files, you can get some ideas.
Okay, thank you.
You're welcome.
This is Jakuba. He is Jakuba.
Okay.
Yeah, I'm Ifali actually.
Okay. All right. Did you have a question, Yakuba?
Not actually, not right now. Thank you.
Okay. All right, all right, all right. All right, Jacoba. Thank you. Thank you for being here. All right, so let's move on to next thing is
Can I translate it first?
okay. Oh, what did you say?
Can I translate like the question and the answer?
Ah,
So-
okay.
Donc, la question, c'était de savoir si sur MATLAB, vous avez aussi un CV Bridge. Donc, vous pouvez avoir, vous avez CV Bridge sur MATLAB. Donc, pour plus de détails, il faudra regarder la vidéo, l'enregistrement de la session du vendredi passé.
Thank you. All right, so moving on, I will do briefly just to show you a little few things about how to understand digital image and about their properties. Okay, so let's do that. So properties
Donc,
of digital image.
On va parler brièvement sur l'image numérique et leurs propriétés.
All right. Okay, so I'm going to create a new file. I'll just call it basic image.
Donc, il va créer un nouveau dossier dans le même script.
Okay, we can copy some of the structure here. Put it here.
Donc, il va recopier la structure du précédent code.
We don't need many things. We don't need any ROS. So we remove ROS. Okay, all right. So we'll just do this together. I want to maybe just share some ideas. The first thing that we'll do is to read the image, okay? We're going to read the image from directory.
Donc, la première chose qui sera faite sera de lire l'image.
The name of the image is front cam image of JPG. Okay, so this is going to read the image. This reads the image. Okay, I don't put any specific directory information because I put it in the same folder. Okay, so it's in the same folder. I can just give it the name.
Donc, comme c'est dans le même document, dans le même script, tu pourras juste écrire le nom de l'image.
Okay, and we can use some error handling to make sure that in this case it should be fine, but there's some error handling in case you actually don't have the right image or the image is not in the right folder. You can get the right information.
Donc, dans le cas où l'image n'est pas dans le même dossier, vous pouvez toujours déterminer une erreur.
All right, so the first thing I like to do is to inspect the data type. Okay, so the question is, what is the data type of this IMG? Okay, so OpenCV reads this image, that's this one here. Okay, OpenCV reads this image and saves it as IMG. Okay, but what is this IMG structure? So we can ask that question, okay?
Donc, la question est de savoir quel est le IMG de l'image.
And I just want to show us what that is like. I can print it out when we run, okay? We can use the command type to check, okay? So we can run this and we should print out the image type. Okay.
Donc, pour
So I can do
pouvoir
that on
connaître
this slide.
le type de l'image, vous pouvez écrire comme c'est présenté sur la ligne 16 et regarder le terminal pour savoir quel est le type d'image.
All right, so when we run it in terminal, you have OpenCV image data type is NumPy array. Okay, so it's a NumPy array. That is a matrix. NumPy array is like a matrix. Okay, so that is one thing we know. What is the shape of this array? That is the next thing you might want to know. Okay, it's an array. What is the shape?
Donc, comme vous pouvez voir dans le terminal, vous avez le type d'image que vous avez que vous avez devant vous. Ensuite, vous pouvez vous poser la question de savoir quelle est la forme de l'image. Vous écrivez encore une autre ligne de code.
Okay, so I'm going to print the image.shape. And you can
Vous allez
see now.
Ouais.
So the image has the shape of the matrix is a three-dimension matrix that has, and this has 3 channels. So the third one means channels, and the size of each channel is 480 by 640. Okay, so this is X, this is Y. I think about X and Y direction, and this is the channel.
Donc, vous allez être capable de lire, de print la ligne de code que vous avez écrite par rapport à la forme. Ensuite, comme réponse, vous aurez une réponse en 3 dimensions, c'est-à-dire le 3 pour channel et 480 pour X et 640 pour Y.
Right. And this it looks very similar to what I showed you here. You see, this is a matrix. This one is 3 by 3 by 3. Okay, so it's 3. That's 3, 3, and then 3. So this is just a 3 by 3 by 3 image representation. But the one but this image actually, this image that we processed is 480 by 640 by 3. Okay.
Donc, la métrique, c'est une matrice de 3 x 3 x 3. Donc, comme vous pouvez le voir pour l'image spécifiquement, c'est 480 x 640 x 3 matrice.
All right, so we have 480 down like this. So this is X. Y is 640. And then there is 3 channels, like we learned, is RGB. So each pixel here will have R value, G value, and B value.
Donc, chaque pixel de l'image aura 3 valeurs, la valeur de R, la valeur de G et la valeur de B.
Okay. Any questions about that? Anybody? No? At least for me, the next question I'd like to ask is, well, what do each of those channels look like? So we can split the data into channels.
Donc, ensuite, vous pouvez vous poser la question de savoir à quoi ressemblent exactement toutes ces chaînes.
We can use the split function to split a multi-channel image into its different channels. Okay. And I will.
Donc, vous pouvez utiliser la fonction split.
For the interest of time, I will copy some code I already wrote before that will help us to plot and show all the different images.
Donc, il vient de copier un code qui va vous permettre de graphiquement voir les chaînes de chaque image, c'est-à-dire RGB.
All right, so I'm importing All right, so what I'm going to do here is, what I did here actually is, I want to show all the channels, okay? And the original, so you can see what the channels look like.
Donc, il faudrait voir toutes les chaînes, c'est-à-dire bleu, jaune, enfin, bleu, vert et rouge.
Okay, so the image color is a little bit distorted, but in any way, you can see that these are the three channels. This is the original image. The color is a bit distorted, but you can see the blue, green, and red, and you can see that, you know, different pixels have different magnitude of blue, green, and red that makes up the final image. Okay, so you can play around with this also when you get a chance. This was to plot. Okay, so I will also have this code in the repository, so you can also use it directly yourself as well.
Donc, vous pouvez avoir accès à ce code après la réunion aussi.
Okay, so we just saw a few things. One thing we saw is that OpenCV in Python saves the image as a NumPy array, and the shape, we can see it is a three-dimensional matrix, X by Y by channel. And we can see how we can use the split function to split the channels, and we can plot the different channels and see what they look like.
Donc, nous avons vu comment enregistrer une image, comment déterminer la forme. Comme nous avons pu le voir, c'est une matrice à 3 dimensions, X par Y par channel. Et on a aussi vu comment split les fonctions pour split les RGB.
All right, thank you. So we have done this part. Also, I left a link here to a web page that has some information about how to do some basic operations.
Sorry, can you paste this link on the chat, please?
Okay, I can do that, yes.
Thank you.
But also you get access to this, but I can, if you want to look at it right away, yes, I can. Oh, wait, sorry. It should be to everybody. Oh, sorry, I've not been looking at my chat. Okay, all right, very good. So the next thing is some basic image processing. Okay, now I want to talk about basic image processing. This is the last part for today, okay? How to do some image processing.
Donc, on va parler maintenant des traitements de l'image, des basics des traitements de l'image.
All right, so the first thing is how to convert from one color space to another color space. The basic color space is RGB, like we already looked at. But sometimes when we want to analyze, we want to process our image, we can convert from one color space to a different one that has a better way of distinguishing parts of our image. So for example, today we're going to see how we can convert from RGB to HSV. HSV stands for hue, saturation, and value.
Donc, on va apprendre à convertir une couleur à un autre état, c'est-à-dire convertir de RGB à HSV. RGB a peut-être des couleurs basiques, mais HSV a un peu plus de couleurs, je dirais.
So it's just, if you can see from this image, it's just a different way to, it's a different way to process the information, a different way to represent the image with different dimensions. And so that's what we're going to use. So let's go into it immediately. I'm going to again create a new, I'm going to create a new script. Okay, I want to put everything in different scripts so it's easy for you to follow later. Okay, so image processing, another script. Again, we will borrow from structure from a different code. Okay, we can remove some things, but other things we will keep. Let us remove everything from here. All right, so we remove, so I don't need this actually. No need for the CV bridge. All right. So the first thing I want to do in terms of processing, let's see, was to convert. We want to do converting from, so we convert from BGR to HSV, okay, or RGB. RGB or BGR. In OpenCV, it is BGR instead of RGB. Okay, that's what we have.
Vous allez ouvrir un nouveau document dans le même script. Vous allez utiliser la même structure, enlever quelques éléments. Ensuite, vous allez établir sur la ligne 14 la conversion de RGB à HSV, mais sur VS Code, au lieu d'écrire RGB, vous allez écrire BGR.
All right. Thank you. So we use this function called convert color. We can put the image that we want to convert, and we can say what to convert to. So we say color BGR to HSV, and it does it for us. Very simple.
Donc, vous allez utiliser la fonction convert color et établir le type de conversion que vous voulez.
All right, and then we can display. So what we're going to do now is we will display, we'll display both images.
Donc, vous allez afficher les images, les différents types d'images.
All right, so I did that. So I'm going to run this on my terminal. So remember to run the right one. Now we are in image processing. All right, so image processing, we have it there. Let me raise this up.
Donc, vous allez aller dans le terminal et donner le nom du file dans lequel vous êtes.
All right, and we have the two images. This is the BGR.
Vous avez les deux images, le BGR et le HSV.
All right, so BGR, HSV, the two color spaces that we can convert from one to the other. Okay. All right. So that's it pretty much for that process. You see, that was quite easy. Just use this one function to convert to HSV. Okay.
Donc, vous allez utiliser cette fonction pour convertir en HSV.
All right. If you have a question, please go ahead and ask. The next thing I want to do now is how to do thresholding. Okay, so you see, this is GBR, BGR, this is HSV, and now we want to be able to distinguish or to extract our crop row. This is what we want, because now maybe we can use this to find a way to follow the crop roll in our navigation, right? There's a way we can try to follow the crop roll. How do we get this image from here?
Can you repeat it again, please?
Yes. There are many things that we can try to do once we are analyzing or processing our images. For task 1, for example, we can try to find a way to extract our crop roll from each image and find a way to follow the crop roll. Okay, so this image here is showing us how we have extracted the crop roll. This is the crop, this is the crop. You see, this is the crop. And we have removed everything else apart from the crop roll using some thresholding operation. Okay, so I'm going to show you how to do this. It's actually very simple. And then once you have this, you can find a way to follow the crop roll in your navigation.
Donc, vous allez utiliser on va utiliser une opération de seuillage afin d'extraire les rangées de culture de chaque image.
All right, so let's do that now. All right, let's go back to here. All right, I can keep this. You can keep this. All right, so let's go on to another line. So what we want to do now is to do some thresholding. Okay, so thresholding. All right, so
donc, vous allez faire un seuillage. Maintenant, vous allez faire sur la ligne 22, vous allez faire un seuillage.
All right, so the function that we use to create a threshold, I can say, okay, threshold image is equal to CV dot in range. We can put the image that we want to process, the threshold, and we have to put like the color minimum and the color maximum threshold values. Okay, this is the structure that we will use. But we need to set what the color minimum and color maximum will be. Okay.
Donc, vous allez configurer quelles sont les couleurs minimales et les couleurs maximales. Ensuite, utiliser la fonction trace image en suivant la même configuration.
Okay, so the minimum and maximum is really saying, okay, remember that we have, let me go back to this image here. We have this. If we can set minimum and maximum for these 3 axes, so remember we have 3 axes, hue, saturation, and value. We can set range for each of 3 of them so that we can isolate some part of our color space. That's pretty much what we want to do. We can set minimum and maximum value for these 3 values. Remember there are 3 channels. So we can set minimum and maximum values so that we can isolate some part of our color space.
Donc, afin d'isoler certaines parties de l'espace des couleurs, vous allez utiliser les 3 sections, c'est-à-dire la teinte, la saturation et les valeurs.
All right, so there should be 3 values for minimum, 3 values for maximum. So I will just set some random value, maybe 10, 50, 50. This is random, you know. Let's say this one I can say to 150. Actually, it's not random, it's from 0 to 255, but it's random between that range.
Donc, par rapport aux chaînes, vous devrez déterminer 3 channels, 3 chaînes. Donc, il a pris des numéros au hasard.
Okay, and then I can display what I have. So, all right. So after I create this thresholded image, I want to show it. I want to display it. Okay.
Donc, après avoir écrit la ligne de code par rapport au seuillage, il va écrire sur la ligne 26 un code pour affichage.
All right, so that's what we have, okay? So you see, this is the thresholded HSV image. And it's a bit hard, you know, I use some random values for H and S and V. So that's why I got this.
Donc, comme vous pouvez le voir, c'est l'image relative au code et aux couleurs minimales et maximales qu'on a choisies.
All right, so I found a really interesting script or code online that can provide a nice interface for us to do this automatically or easily. So let me copy it here so that I can show you how easy it is to use. This is not my code. This is code I found online. I'll put the reference to the code also. So this is the code.
Donc, il a trouvé un code online qui permettait de facilement convertir le RGB en HSV. Donc, il mettra la référence sur le GitHub.
Okay, so this is how you use the code. You can add the image directly in the argument. And if you run that, you get this. Okay.
Donc, on pourrait mettre, par rapport à ce code, vous mettez directement le nom de l'image sur l'argument. Et
All right,
lorsque
so
vous
I need
allez afficher run le code, vous aurez cette image.
Okay, thank you. I want you to ignore this BGR here. It's supposed to be HSV. But what you can see is that there are 3 channels, okay? There's channel 0, channel 1, channel 2, low, high, low, high, low, high for all of them, okay? And if I change this value, you see that it changes the solution, which is very nice.
Donc, lorsque vous allez run le code, il faudra ignorer l'écriteau BGR. Ça aurait dû être HSV. Et comme vous pouvez le voir, il y a 3 channels. Le channel 1, 2 et 3. Donc, si vous bougez un peu, si vous essayez de manipuler un peu les boutons, vous verrez que ça change la teinte des images.
All right, so now what we can do is that we can move, we can move this bar manually and see when we can get a set of values that will only have a good mask for our crop. Okay, so I can, and this is something you just have to play around. So see, if I move this, you see, can you see that? That is very nice. Okay, I can move this down also. Okay, that looks good. Can move this up. That, if I move this up, that removes the barn, but still keeps the crop. Okay, so I like that. If I reduce this one, oh, it's removing the crop. I don't want that. So you see what we do? Here I can move this one. It is removing other things. Oh, it's removing the trees. That's very good. Oh, but now it's beginning to remove the crop. We don't want that. Okay, so I can pull this. Okay. Now I want to remove this one. I want to remove some of this tree over here. So let's see what we can move to remove the tree without removing the crop.
I think there is the original image on top of it, so we cannot see what you are doing behind.
You cannot see this black and white image here.
No. There is an image on top. I don't know.
Do other people see?
I see both.
Yeah. I don't know. Andrew, are you using your phone again?
Yeah, I'm using my phone.
Maybe it's your phone, that's why. Maybe it might be better sometimes to use your laptop. But no, maybe you may not have power. Okay, but I think this is good. This has removed the everything else, only the crop, right? Everything else is gone, only the crop. This is really nice. So now we can copy these values. Okay, this value is 39. This one is 77. This one is 106. This one is 237. So we can copy this into, how do we copy it? I have only one screen. Okay, so we can copy this here. Remember, we want to copy it here. Okay, so we can copy it here. So this is 39. The next one is minimum is low is 106. The last one low is 124. Okay. Then the first one high is 77. Second one high is 237. Third one high is 198. All right. Okay, so we can close this.
Donc, après avoir highlighted, après avoir surligné les rangées de culture, vous pouvez utiliser les codes qui ont été affichés sur la fenêtre de contrôle qui était écrit BGR, et vous pourrez le changer maintenant les valeurs de color min et color max.
Very good. So hopefully that was interesting for you to see. We used a some code that I got online. I'm going to put it on the GitHub so you can also play with it. But based on that, we're able to get good values for minimum and maximum threshold. Now, if I run our own code, you see what we can get.
Donc, après avoir déterminé ces valeurs, vous pouvez maintenant run le code sur votre terminal.
Very nice. See, now we have this. Okay, this looks good. This is only keeping our crop row from our HSV image. Okay, so this is very good. This is a good place to be, because now we can maybe do some more processing to track this row as you are driving your robot and follow the row. You know, that could be something you can do. Okay.
Donc, cela va vous permettre de suivre plus précisément les rangées.
Any questions?
Est-ce que vous avez des questions?
I have one more thing to do. I want to show you one more thing, how to use this. I want to show you how to use this threshold that we have created now in ROS. Okay. I want to show you how to use it in ROS. But I just want to know if anybody has any questions before I do that very briefly.
Est-ce que quelqu'un aurait d'autres questions avant qu'on passe il va expliquer en quelque sorte comment utiliser le threshold qu'on a défini sur ROS. Donc, si vous avez des questions, vous pouvez les poser maintenant.
No question from my side.
All right, thank you. In the interest of time, I will just copy the code I wrote before already, because usually I like to write the code live with you, but we're already at time up. So I will just paste the code I wrote before, but it's essentially the same thing. Okay, it's essentially the same thing where we are using the same thing that we did before. Okay, let me copy the same. I will copy this. And where is it? No, large example. Copy this and paste it here. Okay, so We're using the same thing that we did before. And if you watch the video from our other ROS introduction to ROS or robotics, you see this same structure when we use a while loop. Okay, and I have not scan data. I will say camera. Okay, so camera, actually no need for that. It's not returning anything. So I'm not going to spend too much time on this. I just want to show you, this is the control loop. Please go back to read, go back to look at the video if you want to get more idea. But the main thing is I'm calling this function multiple times. Okay. And then this is the function, sensor camera. What this sensor camera is doing is that it is, like I showed you at the beginning, it will collect an image from ROS. It will use the CV bridge to convert that image from ROS into an OpenCV image. Then this will convert from BGR to HSV. And then this will do thresholding with the values that we just got. And then this will display the image. That's all.
Donc, à cause du temps, il a juste copié-collé les précédents codes que nous avions fait et il les a agencés afin de pouvoir faire la conversion et le seuillage sur une seule feuille de code.
All right, very nice. So let me run the code. Again, because this is a ROS code, we have to run with ROS. Okay, so we will, in one terminal, we will start up task 1. And then in the next terminal, we can run this code.
Donc, sur le premier terminal, vous allez lire la tâche numéro 1. Et ensuite, sur la deuxième partie du deuxième terminal, vous allez lire le code que nous avons écrit.
All right, but first of all, we need to do something else. If you remember, we need to make it executable. So we do the same thing that we did before. Okay, so we use this command to make it executable. All right. I just want to mention something quickly. If you're very new to ROS or to Python, this might all be a bit confusing. That's okay. We have a lot of resources on the page, on our competition page, that you can watch. You can also send messages on Slack to ask any questions. But if you really want to learn how to use ROS or how to do some of these things, you really need to learn. You need to watch videos. You need to try things out. You need to ask questions. Okay.
Donc, si vous êtes nouveau sur la programmation Python et vous avez toujours des difficultés par rapport à ROS, vous pouvez toujours venir sur Slack et poser des questions et aussi faire des extra recherches par rapport à cela. Regarder les vidéos et faire des recherches pour apprendre.
All right, so now that we have ROS opened, we have Gazebo ready. I can run our new script. And this should open a window with our masked image. Okay, very good. So you see, we have this. This is directly what the camera on the robot is seeing. Okay.
Donc, l'image que vous voyez sur la droite, c'est ce que le robot voit actuellement.
So I'm going to try and move the robot so we can actually see things moving.
Donc, il va essayer de faire bouger le robot afin d'avoir une représentation en live de comment ça peut se passer.
I need to source. Oh. There we go. I need to source. Gotcha. So for that, we can use the teleup launch file. You probably already used this if you set up your robot in Gazebo. All right, so we can use teleup to move the robot. Okay, teleup.
Donc, il a utilisé TeleOP pour bouger le robot.
I'm going to reduce the speed. And then I can move. So see, the robot is moving. You can see that this camera image is changing. You see that?
I feel the robot does not moving.
What?
It does
Can you
not.
repeat?
Yes, the robot does not moving.
The robot is not moving? I didn't get your question. Is that a question or I didn't get you?
No, he's saying that the robot is not moving it.
Oh. Oh, that might be, what, did you see it moving, Andrea?
Yes, I just see it.
Yeah, the robot is moving. Okay, let me move it again. I stopped it actually. So you see, the robot turned. The robot is moving forward now. The robot, maybe, internet might make it slow, but it should be moving.
Yeah, okay, now it's moving. You can see.
Yeah, so robot is moving and you can see this image is also live, updating live, you see? It's updating live. You can keep seeing all the crop rolls. So that is very interesting. We can turn the robot a bit. Oh, too much. If we turn the robot, you can see that its view, as the view changes, we are using the mask continuously on the image directly. So this is one way. If you can find a way to make the robot to follow this white line in this image, you can use this approach to follow the line. You see, that is to follow the crop rule. That is one, that could be one solution to task one.
Donc,
There are many other ways.
Si vous trouvez une méthode qui vous permettra à votre robot de suivre les lignes blanches sur l'image, ça sera une excellente méthode pour la tâche numéro 1.
Okay, so see, we're almost at the end. All right, we are at the end of the crop roll. Very nice. I think that was very nice. Okay, so I'm going to stop here for today. And thank you for giving me extra 10 minutes of your time. Sorry for always going over time. I want to stop here for today. Hopefully that was interesting for you to see how we can use, how we can use OpenCV to do some image processing and to process images live from ROS, and how we can use that to maybe solve our task 1 and task 2. Okay, so what I would do for us is that I will provide all of these scripts that I wrote with you today I'll provide all the scripts to you on in the link I shared. Okay, I'll put it on the website also so that everybody has access to it. Everybody can have access to it. Again, it will be here on the PARC website. It will be here. Okay, it will be here. I'm going to put it there tonight. once I save it, it will be here. So you can go on this page later today. Let me put it in the chat.
Donc, merci beaucoup pour votre attention aujourd'hui. Désolée d'avoir pris un peu plus de temps que prévu. Donc, toutes les informations qui ont été énumérées aujourd'hui, vous aurez accès à ça sur le lien, sur le website.
Sorry, my computer is being slow. All right, so does anybody have any questions?
Est-ce que vous aurez des questions?
Why so quiet? Nobody has any questions? Does everybody know what to do for task 1 and 2? No question from anybody about how to maybe use some of the things that we talked today for your tasks?
Est-ce que vous serez capable de faire la task 2 en fonction de ce que vous venez d'apprendre aujourd'hui?
I think it will be hard.
Can I, just one question.
Yes, sir.
Are we going to connect to a physical robot later?
Yes, sir. So in the second phase of the competition, yes, the teams that qualify for the second phase will be able to connect. First of all, they will they'll be on site in Senegal for 1 week to work with the physical robot. But between June and that date in July, you would have
They will
remote
connect
access.
remotely.
Yes, remotely, and you can collect sensor data from the actual camera on the robot and process it like we are showing here in OpenCV, and whatever, all the things that you need to do, you can do that remotely from June 10 till July. This would be in the last week in July. So last week in July, then you will the teams will fly over to Senegal and have 1 week to work intensively on the robot. And then the last day would be the final competition.
Okay.
Donc, la question, c'était de savoir si les participants auront accès au robot, c'est-à-dire seront capables de connecter leur travail au robot. Donc, Kenny a répondu que seules les équipes qualifiées seront capables de connecter leur robot. Donc, entre la période du 30 mai au 10 juin, ils auront accès au robot remotely, c'est-à-dire à distance. Et ensuite, une semaine, la dernière semaine de juillet, ils auront une semaine pour se connecter directement et physiquement au robot.
Okay.
Right. So does that answer your question?
Yeah, we're trying to connect to a physical robot arm. That's not in this one. The students want to do that, so we had to connect through the MAC address.
Oh, okay.
Okay, so, but we're using Move IT.
Right.
Okay.
That's a different package for interfacing with robot manipulators.
Yes, right. That's very good.
Right.
Yeah, thank you.
Yes, sir. Yes, sir. Oh, Hamidou, did you have a comment or question?
Not yet.
Not yet. Okay. All right. Okay. Well, I would like us to end it here officially. Let me stop sharing my screen, and also I will stop recording. And